everyone. I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about multiple integrals in which quotient bank discussion. So in detail we will discuss about multiple integrals regarding what are the topics which are involved in multiple integrals, how they are connected to the particular topic, multiple integrals, which is connected to our question bank. That is the question bank regarding multiple integrals, short answers which are kept under part A. 20 questions are written in which under part A. The next, the question bank, long answers, 20 questions which are written under part B, and the problem solving and critical thinking, nearly 10 questions are under part C. So the complete the question bank, which is divided into three parts, there is part A, part B and part C, according to satisfying Bloom's taxonomy action verbs. The first three levels, the first level remember, second level understand, third level apply, satisfying this question bank which is prepared for the module 3, that is which place in this curriculum mathematical transform techniques, the subject module 3 multiple integrals, which is framed satisfying Bloom's taxonomy. So we will discuss how the questions are selected satisfying these three levels. So this is actually our question bank, the system, Institute of Aeronautical Engineering, the autonomous, that Hyderabad, which is located. We can see it as the question bank. The subject is mathematical transform techniques. The code which is allocated for is AHSC07. This goes specifically for first year BTech students, the second semester which is occurring. This is UG R20 regular, the syllabus which is prepared. The total the mathematics department team put together, which is prepared this one. Dr. Jagadha, myself is the coordinator for this. So now the Bloom's taxonomy. The Bloom's, it has the 6 levels are there. The first level is remember. So according to satisfy the level 1 questions will be just recalling, recollecting those type of questions which will play a role in the level 1. The second one, after recalling the formulas, how far we are understanding about that. That is the second level Bloom's taxonomy. The third level is apply. So these two levels put together, we will apply, that is application oriented, that is third level. As our subject, that is mathematical transform techniques, that is a subject name in which the multiple integrals is one module. That module, these three levels is satisfying, the questions are prepared. The main reason, the fourth level is analyze. But the subject which is for first year BTech engineering students, so up to level 3 the questions are prepared. The fourth level analyze. The fifth level is evaluate. The sixth level is very high level, that is the BTech, the final year students, these levels will be there. So first here, as the subject for the first year BTech students, these three levels, how they are connected for each questions, that is also we will be discussing. Yes, this is the question bank format. Module 3, multiple integrals, part A, the short answers. Here we can notice it here. This is the question. Bloom's the third level, the question which fits. So when we are writing the third level, compulsory, first level, second level, crossing, we will go to the third level. To what are the things to be recollected, which is written against each question. This is the course outcomes. So totally 12 course outcomes are there. That is which outcome this particular question satisfies also, which is written. So same the format, part A, part B and part C. Nearly 50 questions are written regarding this multiple integrals. Now we are going to discuss not complete problems. The complete problems, each topic already under multiple integrals, nearly 10 videos, 10 to 11 videos are already, which is released in the YouTube channel. So we can see the complete solution. In this particular, this question bank discussion, what we are going to discuss each question, how they are connected to bloops. To solve that, what are we are going to remember? That is, what are the formulas we are going to recollect? How for our understanding system, and to reach the solutions, what are the steps we are following? So we are going to focus mainly in this video lecture regarding multiple integrals. So that is what we are going to discuss now. So now the introduction to definite integral. First, what is definite integral? So the topic is multiple integrals. Before going to the topic, what is the origin of getting these multiple integrals? They are derived from our definite integral. That is a definite integral, which is an integral with lower and upper limits. So if both the lower and upper limits are there, then we will call it as definite integral. This integration, which is used to calculate areas, volumes and displacement. The definite integral, if it is only one variable it has, that is definite. If instead of one variable, if they are connected to two variables, then we will call it as double integral or multiple integral. This double integral, which is in the coordinate system of 2 dimension, that is very, very important. So we can see it, suppose y equal to f of x, which is a function of one variable, which is bounded on the closed interval a comma b. If this closed interval a comma b, we are dividing into n subintervals, that is x0, x1, x2 up to xn, we are dividing. That is, this a and b inside these points are there. So they are inserted from x0 to xn, a equal to b. This is the starting point, this is the ending point. They are included because it is a closed interval. Now, our delta xi, we are defining in such a way that xi minus xi minus 1. Suppose if x1 minus x0, we are replacing in this. If you are taking I equal to 1, it is delta x1. So where similarly we can, that is delta x1, delta x2, up to delta xn we can find. Suppose this point is there, in between here infinite number of points are there, in which our choice we can select any point. That point is ti. So the summation I equal to 1 to n f of ti delta xi, if that is the n which tends to infinity, delta xi tends to 0. The ti, so how the ti which is defined, integral a to b f of x dx, it is a definite integral. we can see it now, the complete what we have seen in this one, which will make us to understand the definition of double integral in a very clear way. That is, a particular region is there, that is in xy plane. That is the function which is defined, the variables x and y. Suppose if you take a particular region, this is R, which is we are dividing into two parts. This is R1 and this is R2. In case, instead of for two regions, we want to divide this particular region into n times. Then again, this is R3, this is R4, up to Rn we are dividing. So if you are dividing this particular thing area, we want it, that is delta R1. This area is delta R2 up to delta Rn. Thus, we dividing the regions, they are non-overlapping. Suppose xi, yi is a two-dimensional coordinate system. Then R1, R2, R3 up to Rn, suppose the area delta Ri, if it is there, we will consider the sum. That is, the function which is defined at the points x1, y1 into delta R1 plus f of x2, y2 into delta R2 up to n times we are writing. If the dividing the region up to n, we will be writing such a way. Suppose the given region, if you are dividing into infinity, then particular situation, then the area tends to 0. So if we are going on, we can imagining this is the given region. So we are going on, we are dividing the region and it should not overlapping also. So particular situation compulsory that region dividing which comes to an point. So that's what here 0 which is written. Now this actually the double integral, this is the way to be calculated. The double integral which is used to calculate the area of the surface, which is in two-dimensional. So here which is written f of x, y into the region is dr. So if it is in xy dimension, then that is the reason here the dr which is replaced by dx dy. So now this is the problem which is in our question bank. So the before one what we discussed defined double integral which is in the question bank. So what we discussed to be written. Now this problem which is in our question bank, that is evaluate integral 0 to 3, integral 0 to 1. Here we are noticing this is the interior integration. The lower part is 1, the upper part is 2. Whereas the outermost integration, the lower part is 0, the upper part is 3. All the four are constants. So there is no problem at all. While evaluating the integral here, dy, dx, it is there. And one more thing, this Bloom's taxonomy, we actually remembering and understanding and apply, the three are there. But in the questions, actually, we can use it, evaluate, that is the verb which is given. But here, the thing is there, the word it is a evaluate, but it is a Bloom's taxonomy. According to that, we are applying up to third level only. This problem comes under. Now, the limits, if you are noticing, all the four are constants. So there is no problem at all. Instead of dy, dx, we can write dx, dy also. So nothing wrong in it. It won't make any difference in the solution. So the question, the interior one, we are going to do with respect to y, and the outer one we are going to do with respect to x. So this part to be concentrated with respect to y first. The result getting this particular place we will substitute, and finally we will do integration with respect to x. But suppose in case instead of this one, if we are asked to solve this type problem, then it is a two-dimension because xy coordinate system, and even the integral also, two integrals are there. So here we can write y equal to because it is the interior integration is a function of x, then which is defined for y equal to 1, y equal to x. So totally 2 x and y is already we allocated for the interior integration. So the outer one is x equal to. So the compulsory, the interior one, y equal to, which is defined for y, we have to do integration with respect to y. So it is correctly with respect to y only it is there. Suppose in case if it is x is there, we have to change it to this format. So the integration how to do, it is a simple integral formula. This will be adopting, that is a integral x power n dx, which is equal to x power n plus 1 divided by n plus 1. So we are recollecting the formula. So Bloom's taxonomy, the first level. The second level we are understanding, that is the two dimension is there. The two dimension x and y. Here the coordinate system, suppose dx dy is given. We are checking the limits, the interior integration which is defined for y or x. If it is defined for y, we have to do interior integration with respect to y only. Here suppose the question is this, which is defined for y, but in the problem which is given dx for the integration. So we will modify in such a way. So we went to satisfying the Bloom's second level. Then the third level, completely all the formulas we are going to apply, and we will get the final result. So the next problem is evaluate. Here we can see it. So the double integration dx dy, this is the question which is in our question bank. Here x, y, two variables are there. The interior integration, which is a function of x, then y equal to, we can write. Compulsory it should be, if it is for y, the outer one is x equal to. Part of the question, the interior one to be integrated with respect to y, but here in the question with respect to x is there. So we have to change the question. So the question just we reproduce it, and here we changed it. Why the changes occurred? So the two dimension, because interior integration is a function of x, then we have to do the interior integration defined for y, then we have to do integration with respect to y only. So the second level Bloom's is satisfied. First level, second level satisfying. We are going to apply all the formulas what we recollected, what we understood about the double integral. Applying the third level, we will reach the solution. That is, first we will be focusing on the interior integration. That is a simple integral formula, integral x power n dx using, we will find this result, and that result to be substituted in this particular place. Then with respect to x, for the outermost integration we will be concentrating. So the next one, the problem we can say it, evaluate or the interior integration which is 0 to 1, The outermost one is 0 to 1. Dx dy divided by square root of 1 minus x square into 1 minus y square, which is given in the question. The solution, just we have written what is given in the question. All the four are constants, so there is no problem at all. There is no question of modifying this dx dy. Even we can write dy dx also, because all the four limits are constants. Just regarding that, we recollected, we remembered, that is to satisfy Bloom's first level. The next we are going to focus this interior integration. First we are going to concentrate. That's what the separate bracket which is put, and the outermost one we didn't touch at all, just we have written. So the first separate, the interior integration we are calculating. So this is the again the integral, the basic formula what we have studied in lower classes, we are recollecting. So this is the integral formula is sine inverse x from 0 to 1. So we are substituting in the particular x place upper and lower limit. This is the negative sign which is in the limit formula. So we evaluated this our interior integration. Yeah, this is our question. We evaluated only this interior integration. This interior integration we evaluated and we obtained the result pi by 2. So that particular place we replaced it. Now we have to concentrate the outermost integration, that is y from 0 to 1. With respect to y, we have to do the integration. So they say sine inverse y, and we will apply the limits upper and lower. We will obtain the final result pi square by 4. So if you want in very detail the step by step for everything, because here we are discussing in this video lecture to reach the solution, how the question, on what basis it is selected according to Bloom's, and what are the formulas we are recollecting, the formulas how far connected to that problem, the understanding level, to reach the solution, more what are the things we are defining to reach the destination of solution, we are discussing in this video lecture. So the next, actually this is the problem in our question bank, that is here noticing only the interior integration which is defined as a function of x. It is a function of x, then we can write y equal to, compulsory it should be integrated with respect to y, but the question which is given dx, we have to change the question, we have to modify the question. So we modified it. So the interior one we will be doing integration with respect to y. So here we can notice it, the interior integration which is kept separately. After doing this interior integration, the result will be substituted in this particular place. So after in the particular place substituting, finally the outermost one we will be doing integration with respect to x. So now, so far we discussed about mostly the Cartesian or the system, that is xy dimension, that we discussed. Now this is the question which is in polar form, that is radius and theta, they are dominating. So radius and theta, they are dominating in the system. So the question which is kept here as it is, We are going to concentrate the interior one. We have written in a separate bracket. The first, the interior one, we will evaluate. We are going to do with respect to theta. That's what this is kept outside. Here d theta. So the d theta, the integral is here theta from 0 to pi by 2. Here we have written here e power minus r square r. Upper and lower limit we substituted in the place of theta. We obtained this is the result. But our question is this one. Interior integration. We obtained this is the result. So after obtaining this particular place, we substituted the result and we will be doing the integration with respect to r. So to do the integration, we can adopt the substitution method. Adopting, finally, we will reach the solution. First, in this problem, the question first we modified it. The question, the polar form, which is given, we separated the interior integration. Separately, we have done it. We obtained this is the result. That in this particular place, we put it. Then final integration for the outermost one with respect to r, we are concentrating, for which to do this integration, we have obtained r square equal to g. That is 2r dr equal to dt. So when we are doing the substitution method and we have to check is there any changes in r, because here the complete system which is with respect to r, the integration is there. The complete system we are going to change towards t. When we are changing the system from r to t, we have to check is there any changes in the limits also. So all the formulas, the basic we are recollecting, Bloom's first level, and here correctly we are going to understanding the second level, how it fits to our problem, understanding Bloom's second level, which is satisfied for this problem. The third one, we will apply all the formulas correctly to our problem. So up to 3 levels, this problem Bloom's which is satisfied. Now, when r equal to 0, t is 0. That is in the place r place we are substituting 0. If you substitute here infinity, t is infinity. So we are coming to a conclusion that there is no change in the limits. So the same, the limits retained its same position, and r square which is replaced by t, what we assumed it, and our dr it's nothing but from which we are obtaining dt by 2. So this we will do the integration, and which is kept in the previous slide. What is that? Here this 2 we put it outside and we did the integration, that is e power minus t. That is the integration is e power minus t divided by the t coefficient is minus 1. E power minus infinity, the value is 0, and e power 0 equal to 1. That substituting, you can see it here, all the substitutions, upper and lower limit. This is the negative symbol for the limit formula, and here the e power minus infinity value which is kept. E power 0 is 1, this negative sign here. Finally, we reached the answer pi by 4. The next problem which is dominating in our question bank, which is integral 0 to pi by 2. That is the outermost one from 0 to pi by 2, whereas the interior one from 0 to 2a cos theta r square sin theta d theta dr. Here the same way we will be doing the interior one. This is the interior integration is a function of theta. Then r equal to, which is defined for r. Then we have to do integration with respect to r first. But in the question, d theta is there. So we have to modify dr d theta. This to be done first. Then we will concentrate. So the interior integration with respect to dr first we will do it. Then outermost is d theta and we will achieve the result. So the next problem is, here we can notice it, the interior function. This all the equations which are dominating the subject, mathematical transform techniques, the third module, multiple integrals. According to 90% apply up to Bloom's third level, which is prepared. Why it is up to third level? We didn't go for the fourth level analyze. Up to 90%, there is up to 3 level as the subject, the main reason for the BTech first year engineering. Here we can see it here, this interior integration that is from 0 to a sine theta or dr, which is given here. So the integral integration is a function of theta. So r, which is defined it, r equal to 0, r equal to a sine theta. So dr to be, there is not required any modification in the equation. So here with respect to r, the equation itself, which is in the correct form. So we have written as it is. So the interior one, the separate bracket, we kept it. So we are going to focus this inside the bracket one, that is the interior integration. Here only keeping we can do it, otherwise separate doing in this particular place we can substitute. Anyway, the simplifications can be done. So r, that is a simple integration, r square by 2 from 0 to a sine theta. Substituting upper and lower limit, we will attain the result that to be substituted in this particular place, and finally with respect to theta, and we will apply lower and upper limits, and we will get the solution for this particular problem. So the one more the problem is the interior integration, that is a function of theta. So which is defined r equal to, then the outermost is theta equal to. Immediately, that is how we are, this is understanding level. The Bloom's second level. We are understanding because the interior integration is a function of theta. Then it is in polar form, r and theta, radius and angle, they are dominating. So when it is defined for r, we have to do integration with respect to r first. Correctly, it is in the question which is in the form. No need of any changes in the question modification. So as it is, we have written the question, and what we are going to do, this part we are going to do the interior integration with respect to r first. So we kept it in the separate bracket. This r, the integration is r square by 2. Anyway, the 2 is constant. In the place of r only, we are going to substitute the upper limit. That is the reason we, the 2 which is kept outside. Here, specifically when we are going to substitute, r is going to take the upper limit a of 1 plus cos theta. That is a square of 1 plus cos theta, the whole square. The particular, whenever the trigonometric functions, if they have power relevant, the formulas to be substituted. So we are recollecting this formula. With the help, we will reach the solution. So when we are actually solving A few steps only actually in these problems which are explained, because more problems are there. Nearly already explained 50 problems which are there in this model multiple integrals. So important points of that are problems we are discussing. But if the students want the complete solution with a step-by-step explanation which is required, these all the problems separate videos are done under different topics regarding multiple integrals. Now come to the point of this problem integration. We are noticing the cos which has the power, even power. If specifically, if for the trigonometric the terms, if they have even or odd powers, this is the formula. We can see it. If this place the particular n which is even, this is the formula to be applied. If it is odd, this is a formula to be applied. So completely we can see it. This is a 4x a square, and our n is 4, 4 minus 1. Here also n place we are substituting 3 by 4. So same like that in this formula selecting, we attain to the result 3 pi a square by 4. So completely the trigonometric formulas we recollected in this particular problem. And the question is, there any changes are required, as it is a two-dimension or understanding level which is increased from remembering level to understanding all the formulas we obtained in a correct way, and we reached the solution 3 pi a square by 4. That is the three levels Bloom's satisfying the problem, we solved it. So the next question is, evaluate double integral xy by square root of 1 minus y square dx dy. It is in Cartesian form because the variables x and y, they are dominating. So over the first quadrant of the circle, x square plus y square equal to 1. Before, so far what we have discussed, only evaluate integration. They didn't give any bounded region condition. That is geometrical figure, which geometrical figure which is not given. So far what we discussed in those problems. So this specific problem here, x square plus y square equal to 1. Yeah, we are going to recollect this formula where we studied. Yes, we studied equation of the circle. X square plus y square equal to r square or a square. This is a format already we studied. So that circle, and one more thing, first quadrant it is there, two dimension. So we have the four quadrants, but our circle which lies in the first quadrant only, according to this problem, we are going to consider. First, what is first quadrant? The meaning we are recollecting, and we are recollecting equation of the circle. Bloom's first level is over. The next we are going to define how far it is going to fit to our problem. Looking at this, we are going to draw the figure. Second level we are going to complete, that is Bloom's understanding. It's a two-dimension. The origin, we named it as O. The coordinate is 0, 0. X-axis, Y-axis. And the figure, first quadrant. So that is the reason only 1/4 of the circle which is drawn here. We can say it. So this is the circle, the equation x square plus y square which is equal to 1, which is given in our question. And this is the point, that is P of 1, 0. Here 0, 0 is there. That at x equal to 0, what about y? At y equal to 0, what about x? So we will be getting plus or minus the values. But here, first quadrant, our circle lies. That is the reason negative points we are not going to take, only the positive. So that actually the if x equal to 1, there is a point on x-axis that we are naming as P. Here Bloom's second level. Here there is a point y on y-axis, that is when x equal to 0, y equal to 1. Here when x equal to 1, y equal to 0, we are considering only positive points because of the reason first quadrant, our Bloom's second level is satisfied. This is the bounded region area we have to calculate. The double integration, the basic concept is, which is used, the double integration to calculate the area of the surface. So to calculate the area of the surface, two methods are there. We can calculate in a vertical way, that is, this is the way. This is the way we can calculate. Or this is the horizontal way we can calculate. Either two ways this area can be calculated. So now we are going to calculate a vertical way, for which we have taken one vertical strip. That is the vertical strip, the name what we have given is A and B. When x equal to 0, we got it y equal to 1. When y equal to 0, x equal to 1. That's what these points which are plotted. So now this area we have to find. The better one, the curves regarding whatever it is there, that we will keep it for the interior one. Now this vertical strip, where it starts here. That is here, what is the y coordinate if you are seeing, that is 0. Where it ends, it is touching this circle, it ends. So from which, what is y we can extract. So from which y square equal to 1 minus x square, y equal to square root of 1 minus x square. So this interior integration limit, we obtained it. The next one, x. The x1, this is the vertical strip. The vertical strip, the left side, what about x? 0. Here the right side, what about x? 1. So x is playing the role, the lower from 0 to 1. The function what is given, we have written as it is. But one thing we are noticing, the question which is given dx dy, but now we have written dy dx. The reason is the interior one we define for y, so we have to do integration with respect to y. So the first we will be focusing this with respect to y integration. After solving, finally the outermost we will concentrate for x. So here finally the applying Bloom's third level we reached to attain the solution for the given problem. So the next one more problem, the double integral x square minus y square dx dy over the triangle. Here the three vertices, the coordinates are given 0, 1, 1, 1, 1, 2. So reading the question, it is a two-dimension because here the variables are x and y. This is the point. We named it as O, 0, 0, x and y. So here we are plotting the points. So we can see it here. This is the P, here 1. These points, what is given in the question 0, 1, 1, 1, 1, 2. They are plotted and we named it as PQR and we obtained a right angle triangle. Here also the same vertical way we are going to evaluate the double integral, for which the vertical lines which are drawn here. We are going to take a vertical strip. We named it as AB. Here, this, the vertical strip, if you're noticing the vertical strip to evaluate so far the previous problem, also we discussed taking the vertical strip. The vertical strip that starts with this line, ends with this line, but we don't know what is this equation of this line and this is also. So we have to recollect that is what we studied in analytical geometry, that is passing through 2 points. What is the equation of the line? That formula we have to recollect for this P and Q passing through 2 points. Substituting in that particular formula, we will be getting an equation. Similarly, PR also. This is the coordinate system. The points, the 2 points passing through the equation of line using the formula, substituting we will be obtaining. So when we are substituting here, we are getting y equal to 1. Here we are getting y equal to x plus 1. Now first, what is that region? That is the region what we have drawn here. Looking at the figure, understanding, we have drawn the figure, the geometrical figure, right angled triangle. The name is triangle PQR. The equation, the PQ, is nothing but y equal to 1. This is the analytical geometry, y minus y1, which is equal to, here we can notice it. This is the point, x1, y1, x2, y2. Here y minus y1, y2 minus y1 by x2 minus x1, x minus x1. In that formula, we are substituting, we obtained, this is 1. In the similar manner, these 2 points also passing through the equation of line we will be finding, we obtained in the same formula. So, obtaining the interior one, the integration, the limits, that is the vertical strip touches this one, that is y equal to 1. It ends with this line, that is y equal to x plus 1. So, which is defined the interior one for y, so the outermost one for x. So, the first we will be focusing on the interior integration. Then, with the result, after substituting upper and lower limits, we will focus the outermost one to reach the solution and satisfying Bloom's third level apply. So, the next problem, which is in polar form, that is looking at that because r and theta, they are dominating. Here the circle r equal to 2a cos theta, which is given. So we can see it, the solution which is written here. So we will draw the diagram. That is the origin. We named it as O00, and the circle which is drawn here. So this is the complete the bounded region area we have to evaluate. When in this point is there, here the angle is 0, so theta equal to 0, which is written. We know it, this is up to here, the theta up to 90 degree, whereas opposite one is negative. Just one arrow mark which is written, that is from here we know it, that is from here, this is actually the complete one, the bounded region. The starting is origin, it is ending with a strip we have taken. Because we need to move the problem, any strip is there, where it touches, where it ends, then easy to evaluate the integral limits. Now it touches with our circle, the circle which is given the condition is r equal to 2a cos theta. The strip name is OA. So now we can see it, our interior integration, the question which lies in polar form. So we can see here the polar form r and theta. So r and theta, the interior one we allocated for radius. So the radius here, the origin from 0 to it touches the circle, so 2a cos theta. The question as it is written, whereas coming to the point of the outermost integration, minus pi by 2 to pi by 2, the outermost, after finishing the interior integration, we will move to the outermost one to reach the solution. First, what are the formulas we recollected? And the next, looking at the question, understanding the Bloom second level, we have drawn the diagram. And finally, our double integration in our given question, after remember and understanding everything, we applied and reached the solution of this given problem. So the next the question is that we are noticing here the double integral 0 to infinity e power minus of x square plus y square dx dy. So for Cartesian we discussed and polar form discussed. Now suppose this is a question which is dominating in our question bank of our module 3, multiple integrals by changing into polar coordinates. So first, what is the question which is given in the Cartesian form? According to that, we are drawing the diagram. Step by step, we will see this particular problem. First, actually, this is x direction. We can notice it, the horizontal lines which are drawn. That is from origin to 0 to infinity, the horizontal lines. How much the unit, suppose x, it move, these lines also will be moving. Now 0 to infinity, so that we are going to draw. That means we are going to evaluate the area. The next diagram we can see it, because this is our question. This question, the outermost, that is the y dimension, the vertical lines we can see it, how our y dimension, it extends up to infinity. Even we are going to our evaluating the area also which is increasing. Now we can see this diagram that is put together, that is horizontal way up to infinity, even vertical way up to infinity. But this, the question which is asked, particularly to solve not in Cartesian form way. Specifically, it is mentioned the Cartesian form, the question which is given, change into polar form, and we have to do the evaluation part. So when we are calculating polar form, we need a radius and angle. So when as it is x dimension and y dimension, which increases, the area also increases. So it is a basic concept, even radius also increases. So x and y tends to infinity, our r also tends to infinity. So completely our area which lies in the first quadrant only. So here at this point, our angle is 0, which lies in the first quadrant. So theta equal to pi by 2. So here what is given according to the question, the limits we are writing, that is x from 0 to infinity, y from 0 to infinity. What we are going to find the integration which lies in the first quadrant. So this is the basic concept. Knowing also we can draw the diagram, and it's a polar form, easy way to evaluate the integral. This is the best way, that is x equal to r cos theta, y equal to r sin theta. Then we can evaluate. That is wherever x, we will replace it by r cos theta, y which is replaced by r sin theta. And what about dx dy? That is replaced by r dr d theta. That is Jacobian of dx dy. Jacobian, another formula, that is applying in that this dx dy, which is converted into r dr d theta. So completely substituting everything. So we can see it here. So this is the equation, and this the diagram. There's a grouped one which is kept again, and this completely we understood, that is a origin our radius. It starts from origin and it ends with infinity. So that is the reason r from 0 to infinity, theta 0 to pi by 2. So they are replaced. This is for r, this is for theta. So evaluating the interior integration with respect to r and with respect to the outermost theta, we will reach the solution. So next, actually, when sometimes the integration, they are very complicated one, which makes our time also more spending to find the solution of the particular problems if the integral is a complicated one. In such cases, we can adopt this order of integration concept. So the order of integration is a thing that is what we discussed so far, the problems, vertical strip or horizontal strip. Two ways we can evaluate the areas. So suppose vertical strip is there, we can convert it into horizontal strip, or horizontal strip is there, we can convert it into vertical strip. This is the basic for the change of order of integration. So that we can see it here. Here suppose the interior integration is there. It is a function of x, that means defined for y. We are finding, suppose this function, the integration, which is very complicated, then we will touch this order, we can change it. So such type of problem, here we can see it, which is in our question bank is there. That is the interior integration, that is from x to pi. The outermost one is 0 to pi. The function which is given, sine y by y dy dx. So first we are drawing the diagram, that is the two dimension. Here looking at this x and y, and the origin, the name is O, and the coordinate system is 0, 0. We have drawn y equal to x because here the looking at the question, Bloom's second level, here the interior integration is there, is a function of x and pi. So y equal to we can write. So y equal to x, it's a straight line. So we have drawn it. Y equal to pi, so there is a point on a y-axis. So we have touching the y-axis a line which is drawn, y equal to pi. Then this is 0 pi. This is using this, we can write pi comma pi. This is the region we have to find, for which we have taken the vertical strip. But vertical strip taking the limits, which will make us very complicated more. Better we will change this limits one. How? The vertical strip A and B. So this is our question. Some basic formulas we recollected. And the second level, understanding Bloom's taxonomy. Understanding the second level completely, we have drawn the diagram. So according to the question, this is the diagram which is drawn. Now the third level, we are going to apply what is the condition of change of order of integration. That is, this is our given problem condition diagram. So that's what which is written. This is given question, the diagram. Now we are going to change according to the condition of change of order of integration. So we can do the comparison. Everything is similar. There is same, this and this diagram. Only the difference is here vertically evaluated. We decided to do it, but change of order of integration that is given in the question. So from vertical to, we are moving to horizontally. The lines which makes the difference, here vertical, here horizontal strip is there. Now according to horizontal strip, the condition where it touches, we can see it. The name we are giving A and B. So this is now according to this diagram. Now this x equal to, here we can notice it, 0, and this that touches this line. This line is nothing but x equal to y. We can see it. So the outer x is over defined. Previously here we defined y equal to. Now we defined x equal to, because this is given question diagram. But we are finding the integration is complicated one. So we are moving to the change of order of integration. From vertical strip to horizontal strip we moved it. According to that, here x equal to 0, x equal to y. The outermost is for y. We can see it here, 0 to pi. So this is the best way. If the integration, if they are complicated, we can evaluate. So now we discussed so far about the double integrals, which are in Cartesian form, polar form, and the transformation of coordinate system, that is Cartesian to polar, and change of order of integration. If our definite integral, which is connected to two variables, then double integral. If they are connected to three variables, the same concept. If three variables, three dimension, then it is triple integral. So now we can see this is the formula for the triple integrals. The interior one, that is from Z1 to Z2. The outermost one is Y1, Y2. The final one is X1, X2. So the interior one, Z1, that's with respect to Z. The middle one with respect to Y. The outermost one is X. So we can see this is Z. So Z1, Z2. And compulsory, if you are writing here the Z equal to, it is a function of X and Y. The second one is Y we are allocating. It should be a function of X. That's what which is written. The final one is X. It should be constant. So we can see this problem, the triple integral. All the 6 limits are constants. So any form it can be written, either dx dy dz or dz dy dx. No need to worry about these dimensions, whatever order they may be. So the first, as it is, we have written. So that's the reason here, which is all the limits are constant. So the integral, we can do it in any form. So then, but when we seen the previous problem, this problem, lots of difference it is there. The previous problem, all the limits are constants. That is coming to here. This is a 3-dimension. This interior one is a function of X and Y. Then Z equal to, which is defined. So X, Y, Z. Z work is over. So the leftover is, here it is a function of X. Compulsory we should allocate it for Y. So Y work is also completed. So the final is X. Yeah, simple way, we won't get any careless mistake. But the interior one is for Z, which is defined. So we have to modify the question. This is very, very important point when we are dealing with the limits. So we can see it as it is, which is written. So we did the modification. That's what which we expanded. So very, very important point to be noted. What we are doing this question bank discussion. The limits we have to check it first. According to that, in such order with respect to whether it is X, Y, Z to be done integration. Now this we will focus it. We can see it here, the beautiful animation which is given here. So first actually the pink color, which is the interior one, that integration we will do it. After doing the integration, we will substitute in this particular place. Then we will move to the middle integration with respect to Y. one result we will obtain, that we will substitute here. Finally, the outermost with respect to x. So we can see to the interior one, this is the result we obtained, because dz, we know it, the integration is z. So one more problem we can see it, which is dominating in our question bank. This is the e power x plus y plus z. E power, the terms are there. The basic formula according to Bloom's, we can recollect it. That is a power. Suppose m plus n is there, we can write a power m into n. Basic exponential law formula, we can recollect it. So we recollected the formula exponential. We have written here. Then it is what is the limits, the formula conditions. It is a function of x and y. So z equal to, here y equal to. We are checking, yes, here there is no need of any modifications and dimensions. They are in correct order. So the first we will be concentrating interior one, next middle, outermost. This is the way the integration to be done. So the next question, which is in our question bank, here we are noticing this is the interior one, which is the function of yz. Then it should be written x equal to. The next one is y equal to. Outermost is z1. Here we can write it. The innermost limits depend on yz. So we have to do with respect to x. That's what here which is written. Here we can see it. This we have to do the integration first. We integrate it first with respect to x we are doing. The next we will do with respect to the middle one y. The outermost, the last one is with respect to z. This part, the limits oriented, we have to be very, very careful. So we concentrated now how to evaluate the area. Now we are concentrating triple integral, double integral related to surface area, triple integral which is related to volume of a particular region. Now the volume integral which is used to volume of a particular region using multiple integrals. We can, if what is the volume we are going to find at the geometrical figure, the region, if it is solid, then the formula which is triple integral dx, dy, dz. If it is a cylindrical coordinates, then triple integral r dr, d theta, d pi. So here the geometrical figure tetrahedron, that is the face, are in triangular shape. That bounded region, we have to find the volume. This condition which are given x equal to 0, y equal to 0, z equal to 0, put together the three dimension. The common plane is x by a plus y by b plus z by c equal to 1. So we will do the solution. What is the bounded region condition which is kept here? So looking at that bounded region condition, it is in 3 dimension. We have drawn it. This is the points we are plotting, and we joined it. We got the triangular, the tetrahedron, but each faces will be in a triangular shape. To evaluate the vertical strip, the bounded region purpose one strip we have taken. The strip this is the surface of that particular geometrical figure. This surface, when we are noticing, it is in xy plane. So we can imagine actually in front of us some, any box, the tetrahedron or any cube or a cuboid. Suppose box is there, the surface is there, then there is volume to find, the height will be there, otherwise depth will be there. So when the surface it is there, the upper part will be 0. That's what here in the geometrical figure itself, here the upper, the dimension, the third one is missing here. because the surface which is related to two dimension, the vertical which is touching here, it is in xy plane. The up, it touches the all the three other dimension, that is this complete plane, this vertical, the strip which is touching. So that we are giving the name A and B. So we have noticed it, the complete the figure x by a plus y by b plus z by c, which is equal to 1. So this is actually the figure which is kept. So here also y should be there. This is x. So now this what is the strip? We have taken AB, it from xy plane. So that's we just now we discussed it. This is the surface. It starts here and it ends with a complete 3 dimension. Imagine we are in 3 dimension now. For 3 dimension, 3 limits of where it starts, where it ends, we want it. This is the origin here, 0, 0, 0. Our z dimension is here. So the z, it starts from 0 and ends. This is the common 3-dimension plane from which we can extract what is z, which is written here. When we are calculating the surface, only this is in xy plane. So when we are calculating the surface, the z is 0. So the next one, from which we can, only this particular part we can extract what is y. Before that, this is a triangle. That triangle is OPQ. It is in xy plane. Z equal to 0, putting this limit, we obtained it. So the next one, we can see the strip names. This is the question, the main diagram. To understand more, only the surface part which is drawn separately. So this is only the surface part. The surface part which is in xy plane, there z equal to 0. So the main plane equation, z by c is removed. So the surface related, this is the equation from which we can extract what is y. So we obtained it. Here we can see it. It starts from x-axis, it ends with y. So we extracted the middle integration, what is y. The finally x is from 0 to a. Here when we are extracting x, this is becoming 0, x equal to a. So this is the way we have to do the calculation. So we can see it, how it works, this volume integral. This is the interior integration we extracted from the main, the 3-dimensional plane. What is z from 0 to a, and the surface integral when we are calculating z equal to 0. So after getting z equal to 0, from which this is the equation, what is y from where to where, finally x equal to from where to where. First we will focus on this interior integration. It is done here. Then we will apply the limits. In this particular upper limit, integral, the limit, the negative sign between upper and lower limit, applying this middle integration with respect to y, that limit to be substituted, and finally we will concentrate with respect to x. So if this particular problem, because what are the important steps are explained in each and every problem, how many questions possible in this video lecture regarding question bank, we discussed it. Full the questions are up to 3rd level, 3 levels satisfying the questions are selected Bloom's. We have to recollect the Bloom's first level remembering, The second level, understand. The third level, apply. The three levels are satisfied, the questions are selected. Now, in this video lecture, what are the important points to get or to remember? What are the formulas to understand what is that level and how to apply we discussed. If want the complete solution, all the problems whatever we discussed in this video lecture, separate videos are done under the specific topics. Now we will come to a conclusion of this video lecture, a question bank discussion for the subject mathematical transform techniques, the module multiple integrals. First we discussed about double integrals. It is in xy dimension. The double integral which is used to calculate the surface area, and the triple integral that is in a 3-dimension xyz, which is used to calculate the volume of your particular region. It is triple integral. And area for the bounded regions, if it is in Cartesian form or polar form. Polar form, if it is radius and thetas will be dominating. Suppose to find this area, the question is given in Cartesian form, we can convert it into polar form. If the integration, which is very complicated integration, the function, then we used the concept of change of order of integration. Transformation of coordinate system, that is given as Cartesian form, how to change it into polar form. And volume of your particular region using triple integral. So all these topics we discussed in detail regarding multiple integrals. Satisfying Bloom's taxonomy 3 levels. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.